Right now, light from your screen is doing something so weird, so completely mental, that Richard Feynman, a Nobel Prize winner, the bloke who literally wrote the book on this stuff, said flat out that nobody actually understands what's going on. Not even him. Stick with me for the next 12 minutes, because by the end of this video, you'll understand the one thing about light that still keeps physicists up at night, 80 years after Feynman cracked it open. And I reckon it'll change how you look at, well, everything. G'day, legends. Welcome back to Curious Physics. I'm your mate, and today we're going on a journey through what might be the greatest detective story in science, what Feynman discovered about light, and the one uncomfortable secret physics still hasn't solved. Let's rewind the tape a bit. Before Feynman, we thought we had light sorted. Newton reckoned it was tiny particles flying through space like little bullets. Then along came blokes like Thomas Young and James Clerk Maxwell showing it was actually a wave, like ripples rolling into Bondi on a good swell. Case closed, yeah? Nah, mate. Then Einstein rocked up in 1905 and said, hang on, it's actually particles again. Little packets, he called photons. So which is it? Wave or particle? Is it both? Neither. For a solid 20 years, physicists were losing their minds over this. And then in walked Feynman with a cracker of an idea that flipped the whole question on its head. But before we get to his answer, I need to show you the exact problem that drove him mental. So come with me. Imagine you're standing in front of a window on a sunny Saturday arvo. You look through it, you see the street outside, but you also see a faint reflection of your own face staring back. Same bit of glass, same moment. How is it doing both at once? Here's what we measured. When light hits glass, about 4% bounces back as a reflection. 96% goes straight through, sweet, simple, consistent. Now here's where it goes sideways. Stack two panes of glass together with a gap between them. You'd reckon 4 plus 4, 8% reflected, right? Nope. Sometimes it's 16%, sometimes it's basically zero. And what controls it? The thickness of the air gap between the two sheets. Let that sink in for a second. The light somehow knows about the second pane of glass before it decides whether to bounce off the first one. That's genuinely bonkers. How does a tiny photon traveling at 300,000 kilometers a second know what's coming up ahead of it? For decades, this broke people's brains. And this is where Feynman had his moment of genius. He said, all right, stop trying to figure out what light is. That's the wrong question. Instead, let's ask what light does. And his answer completely rewired modern physics. Feynman said this: when a photon travels from point A to point B, say from my face to your eyeballs right now, it doesn't take one path. It takes every possible path, all of them, at the same time. The straight line, sure, but also the curved line, the zigzag, the detour via your kitchen, the path that loops around the moon and comes back, the path that goes backwards in time for a hot second, every single possibility. Now, obviously, you don't see light doing laps around your fridge. So how does this work? Feynman said each possible path has a little spinning arrow attached to it like the hand of a tiny clock. When light takes every path, you add up all those arrows. And here's the magic. Most of the arrows point in random directions and cancel each other out. But the paths close to the straight line, those arrows all point roughly the same way, and they add up into something big. That's the path you actually see light take. Beautiful, right? But here's the bit that'll do your head in. This isn't just a clever maths trick. When Feynman used this method to predict real-world measurements, he got answers accurate to 12 decimal places. 12. That's like measuring the distance from Sydney to Perth and being spot on to within the width of a human hair. Feynman's theory, which we call QED, quantum electrodynamics, is the most accurate scientific theory ever created. Full stop. Nothing in science has ever been more right. Okay, hold up. If light is taking every possible path at once, what's actually traveling? Is it a wave, a particle, a cloud of possibilities, a ghost? And this, my friends, is the loop I opened at the start. Because Feynman's answer to this question was, and I'm barely paraphrasing, don't ask. He told his students, nobody understands quantum mechanics. Don't even try, just use the maths. Here was the most brilliant physicist of his generation, standing in front of a lecture hall saying, I can predict exactly what's going to happen, but I cannot tell you what's actually going on. That's the confusion gap that's still wide open today. Quick sidebar because this matters. Remember those little arrows? Feynman turned them into these squiggly line drawings called Feynman diagrams, showing particles interacting. If you've done HSC Module 5 physics in New South Wales or VCE Unit 3 down in Victoria, you've probably seen these pop up in your textbook. Physicists use them every single day, from CERN in Switzerland to the Australian synchrotron down in Clayton, just outside Melbourne. It's how modern physics gets done. But here's the kicker. Even Feynman himself called them a bookkeeping trick, a way to organize calculations, not a picture of what's really happening. He said, "Mate, these diagrams are just accountancy. They're not reality." Now take a breath, because here comes the twist that even Feynman lost sleep over. When physicists ran these calculations, the answers kept coming out as infinity, the mass of an electron, infinity, the force between particles, infinity kilograms per whatever. Obviously, that's a load of rubbish. Electrons don't weigh infinity. So Feynman and a few other legends came up with a fix. They basically said, right, we'll just subtract out the infinities by hand. They called it renormalization, and it works. It gives you those 12 decimal place predictions we just talked about. But Feynman, in his later years, called renormalization, and this is his actual word, a dippy process. He said it was mathematically illegitimate. He said, and I'm paraphrasing, "We've just swept the problem under the rug and pretended it's not there." Pause on that. The bloke who invented the theory said the foundations of the theory are dodgy, and we still use it every single day because it's the best thing we've got. So what's the confusion that's still haunting physics today? Three massive ones. First up, nobody knows why light behaves this way. We can describe it, we can predict it, we can build the internet and lasers and solar panels with it, but we cannot explain why a photon takes every possible path through the universe. It just does. Second, Feynman's theory works perfectly for light and electrons, but it absolutely refuses to work with gravity. Try the same trick with Einstein's spacetime, and the infinities don't cancel out. They swallow the whole calculation. That's why we still don't have a theory of everything. QED is too good to be wrong, but it won't shake hands with gravity. And third, the weirdest one. The moment you try to peek at which path the photon actually took, it stops taking every path. It just picks one. Like it knows you're watching. Nobody, and I mean nobody, can explain why. Buddy, take a beat on that. Think about this next time you look out a window. The light that just entered your eyes, billions of photons a second, each one, according to our best theory, traveled along every possible path through the universe to reach you. It bounced off the moon, detoured through your neighbor's fish tank, went backwards in time, came forwards again, and every one of those possibilities cancelled out except the ones that added up to a straight line into your retina. That's not me being dramatic. That's what the maths genuinely says is happening right now, every time you see anything at all. Feynman once said he reckoned physicists of the future would look back at us and have a good laugh. Not because we were wrong. The predictions are way too accurate for that. But because we were missing something, some simpler, deeper truth underneath. He thought there had to be a more beautiful way to see all this, and we just haven't worked it out yet. 40 years after his death, nobody has. So what did Feynman discover about light? He discovered that light doesn't really travel like a wave or a particle. It explores every possibility the universe has to offer, and what you see is what's left over when all the impossibilities cancel out. He gave us the tools to calculate anything, but he never gave us an answer to what light actually is. And that, my friends, is the most honest scientific story you'll ever hear. A Nobel Prize for building the best map ever made of a territory no human being has ever seen. If this rewired your brain even a little bit, do me a solid and smash that like button. It genuinely helps the channel grow. Subscribe if you want more physics explained the Feynman way. Curious, honest, and not afraid to say I don't know. Drop a comment and tell me what you reckon light actually is. A wave, a particle, something we don't even have a word for yet. I read every single comment. Cheers, legends. Catch you then.